So it's so fantastic. Thank you. Okay, a very good morning to all of you. On behalf of Qcrete Readymix India Private Limited, the organizers, I am Cyrus M. Doherty, going to speak to you on basics of concrete cracking. We are very much used to crack people, but as civil engineers, we are also used to cracks in concrete. And cracks in concrete are caused due to some deficiency in the structure. The deficiency may be due to poor construction, poor maintenance, poor addition and alterations, which many people do. I will be showing you some of them, some examples in this talk, and also poor repairs. A human body and concrete are identical in many ways. I am sure you must be aware of the saying, repeat the dose till the patient dies, or sometimes repeat the dose till the doctor dies. And these are very famous as far as human beings are concerned. If there is a problem in human body, we first go to a medical general practitioner, and if he is not able to diagnose the cause, we consult a physician, and if the cause is serious, we go to a surgeon for an operation. Likewise, a structure also goes to repairs, and we hope the diagnosis of the physician civil engineer are correct. However, for a structure, most often we go for repairs without proper investigation and diagnosis. The repairs are done at a very heavy cost, and at times we don't get the remedy. The repairs have to be done once again, of course, at an extra cost. This lecture helps to identify the defects in concrete by observing the crack pattern. Some of the preventive measures will also be discussed to avoid cracking of concrete in the first place. We know some things were meant to crack, like the egg we have on the breakfast table. The shell suddenly cracks. Similarly, cracks come in concrete too. Concrete is made up of two ingredients, water and cement. And when water leaves concrete, because we put additional water for workability, in addition to what water quantity is required for hydration. On the photograph, you see an egg is cracked before it enters the frying pan. And in the right hand corner, you see a girl has cracked up. She's from Brazil, and Brazil has just lost the football finals. Cracks are of two types, structural and non-structural. Structural are due to externally exposed load. Non-structural are due to intrinsic reasons, the nature of constituents material, like I told you, water, cement, etc. Limiting factors for structural cracks are structural integrity, the structure must stand, it should not collapse, and aesthetics. Nobody likes to stay in a cracked up structure. Like nobody would like to marry a cracked human being. Limiting factors in non-structural is good design. Design means maybe even architectural design as well as structural design and concrete mix design. Proper construction is also very, very important. Proper construction includes skilled workers as well as the skill supervision, experienced and trained supervisors. Why do you like to control the crack width? First is appearance. The structure must look beautiful without any cracks. Second is the durability, because once cracks come, they widen, or even if they don't widen, they allow the moisture from outside, chemicals from outside to attack both concrete and steel. Another thing is water tightness. During the monsoon, we would only like water to come from the taps and not from the roofs. There are two slides in my presentation which I will take a little longer than others. One is types and causes of cracks when concrete is in a plastic stage. When concrete is in a plastic stage, it is like a young child, has to be protected properly. The reasons for the primary cracks, or what we say as the shrinkage or the initial cracks, come one due to constructional movement, second settlement shrinkage, and third is setting shrinkage. I'll deal with one at a time. Constructional movement can be due to subgrade or due to poor formwork. Settlement of subgrade happens, that is the cause. Moisture changes the subgrade, lack of compaction of the subgrade, and remedy could be you must compact the subgrade and control the moisture coming into the subgrade. Otherwise, the props supporting the formwork will start settling and you can have cracks or even a formwork failure. The formwork problem, movement of formwork can happen, swelling of wood or pressure due to wet concrete. Concrete exerts hydraulics pressure, and therefore it has to be properly designed not only for the vertical loads but also for the horizontal loads. Construction of adequate forms is therefore a very important remedy to avoid constructional movements. Settlement shrinkage happens especially when there is a very lean mix being used. The mix tends to settle and has an obstruction of reinforcement and formwork. Settlement of concrete during construction leaves behind cracks inside the concrete, as the heavier material tend to fall first due to settlement and has to go or bypass the reinforcement and formwork, thereby causing cracks. Dense mixes with low water content and adequate compaction of the lower lifts, and therefore this can be remedied or completely removed or controlled. The last is the setting shrinkage. Now, or we also call it as a plastic shrinkage. When concrete is very, very young, just born in the formwork, and the concrete is, the structure is a slab or a thin wall, plastic shrinkage cracks occur when the surface is not protected. Mind you, the surface must be protected as soon as the mason has troweled the slab. It should be covered properly. We'll deal with it in more details a little later. Rapid drying on the surface concrete due to three reasons: high temperature, then of course wind. These are the main causes of cracks. So concrete must be protected. And of course, if you are doing in dry areas, I don't mean Gujarat, dry areas where humidity is low and concrete rapidly loses water from its surface. Cracks are exposed surface due to high wind, low humidity, or temperature differential. These are very, very important and most often occur because people don't take care of properly protecting the concrete at a very early stage. This is very, very important. Many a times people do curing by several methods, sometimes totally inadequate methods, which I'll be showing you, and the slab develops cracks. And mind you, concrete is very young at that time, so these are through and through cracks. So very easily it will allow the rainwater to seep in. We do deal with a little more details of the plastic shrinkage cracks. Mind you, they occur within 30 to 360 minutes. 30, it may take a little longer or it may take even shorter time. So what one must do is one must be prepared when you do thin walls and slab for protecting the concrete surface immediately. Now it is experienced that when evaporation on the surface of the concrete exceeds 1 kg per square meter per hour, plastic shrinkage cracks are expected to occur, and which is generally so in almost all parts of our country, that is India. And it also includes, of course, Sri Lanka and various other places where they have got reasonable winters and other seasons are only warm and hot summers. Reinforcement near the reasons being high ambient temperature, hot sun, low humidity, and high wind. Often people ask a question that why do you need curing during the night? Obvious reason is that winds and low humidity you cannot escape. It may happen at night also. Maybe the hot sun is not present, but loss of water is expected to take place. Reinforcement near the top surface can also cause this cracking. Low rate of bleeding. Mind you, we say when water comes out of concrete, concrete is bleeding. It's supposed to be, water is supposed to be the blood of concrete. Now, when the rate of bleeding is high, water collects on the surface and in one way protects the concrete from cracking because it maintains a good humidity on it, and of course when it evaporates it gives cooling to the top surface, and if the rate of bleeding is low then it will not give the protection and therefore concrete will start cracking. The remedy is use cohesive mixes, avoid gap grading aggregates and cement. When the evaporation rate is below 0.5 kg per square meter per hour, plastic shrinkage cracks are not expected. So you need not do curing. But generally you will always find this parameter exceeding. So one has to do curing not only immediately but also for the specified period of time, which is generally 7 days. Now you see the best way to do curing is immediately as the mason finishes the slab, just put plastic paper or plastic over the entire slab. The one on the left hand side top corner, this is the best and the cheapest remedy. Thickness of the plastic does not matter so long as it does not allow the water to evaporate into the air above. But always weigh down the plastic by either some brick or something else, some weight on it, so that it doesn't fly away. On the left hand side lower slide, you can see people covering the vertical faces of freshly cast columns with Hessian cloth. Now, why I am not recommending a Hessian cloth on top of the slab is because Hessian is porous. Hessian, you have to keep it wet throughout so that water will not dry out from the Hessian cloth. Whereas plastic does not allow the water to leave. You can see the water, the humidity between the plastic sheet and the slab, just like you see when you wear a shirt and you are perspiring, it looks wet and maintains the coolness of your body. This also does not allow further evaporation from the concrete. On the right hand side corner, I am showing you a slab which has suffered from plastic shrinkage and the cracks are right through. This is a photograph taken at the soffit. When the curing was also being done at the top, the water would seep through. Map type shrinkage cracks occur and cover the entire slab surface. Now, no matter what waterproofing you do, it may last you for 5 years or 10 years and again you get into problem. So the best solution is to prevent this plastic shrinkage cracks. People often blame the cement for these cracks, and if they have taken Readymix concrete, they blame the Readymix concrete. But cracks do not occur due to both the reasons. Cracks occur due to poor initial curing at the top surface. Whenever the structural member has a bigger area compared to its volume, these cracks are known to be seen everywhere in all parts of our country. Even where there is high humidity, even where there is low humidity, even where there are temperatures low, even there is no wind, etc., these cracks occur. So we recommended the client who was blaming our cement when I was working in Abuja Cement to put a plastic sheet. The next slab we cast in our presence, putting the plastic sheet, and you can see how beautifully it has come. Not a single crack. You will be searching for the crack. Even the vertical curing should be done with a proper cover of the Hessian cloth. If you are lazy to do proper curing of vertical surfaces, maintain the formwork for some time. Mind you, it should be a wooden formwork and not steel formwork. Otherwise, that will generate heat and you may get cracks due to that also. So you must cover your concrete like a young child, protect it initially, and you will get good results, both from your child as well as from your concrete. Well, I had spent quite some time in Kerala giving lots of lectures, etc. So at one of the site I came across which was plumb opposite a lagoon, and you can say water everywhere, but not a drop to drink for the concrete. Because in Kerala, they had put on one of the sites a tin, and they are supposed to fill it with water, but there was no drop falling on the concrete. So I asked the supervisor or the person who was standing there, what is this for? When do you put water? He said, once in a way, when we climb a coconut tree, we see the water is not there, we pour it. So this is not the way to do curing anywhere. So otherwise the concrete will give you poor results. Instead of putting a tin in rural areas of Bombay, there are very few of them now. People are building their houses, etc. And they put plastic bags with water on the top. You can have a closer view. I call it poor man's curing or concrete on glucose saline. Again, here too, there is no drop of water falling. The Asian is dry and it's not going to protect your concrete or cure your concrete, etc. So these sort of methods are not permitted or not allowed. You have to do proper curing with continuously for 7 days, day and night. Other properties, type of causing of concrete cracking after the concrete has hardened. Now mind you, concrete will harden either within few minutes depending on the ambient temperature, or it will take sometimes days. But generally curing is specified for 7 days. If you are using pozzolanic cement or pozzolanic material like fly ash and slag, then IS recommends longer curing periods, maybe even 14 days. If you are making constructing roads which have huge area compared to the volume of the road or the pathway, then of course you have to cure it for even more than 14 days. Initially, Mumbai roads, when they were concrete roads, just started during the days of the municipal commissioner, Mr. Tinekar. They had recommended, municipality had recommended 28 days curing. As a result, even after the road was cast, the concrete was laid, 28 days the road was not allowed to be used. But what happened was that it was a bit of a nuisance to the residents or the citizens of Mumbai that the road which is made is left for 28 days. Of course, Whether proper curing was done for 28 days is also another question mark. Whether the moisture was maintained so that the concrete doesn't crack is also a question. But due to political reasons, the period was reduced to 14 days. I would say if you can cure your concrete properly for 28 days, please do so. It will give better durability. But of course, there is a feature of time and convenience. The first thing you see here is drying shrinkage. Drying shrinkage is the elder sister of plastic shrinkage. I call it an elder sister because concrete has now become hard. Still, it is losing water. Maybe due to the plastic shrinkage cracks which have already occurred, or maybe due to the use of a mix with a very high water to cement ratio. So concrete has a lot of porosity. Some of them you can't see because it is a microscopic porosity, and some of them you can even see. Cracking of building slabs and walls do occur. The remedy is dense mixes with low cement and low water content, and but most important, adequate curing. This is extremely important. I will show you some of the Mumbai roads which have cracked because of maybe poor curing and also not planning the construction properly. But we proceed now to the chemical action. Chemical action can take place on the concrete as well as on the steel, which is inside the concrete, or what you call as RCC. In concrete, expansion of internal mass can occur, resulting in cracking of the external skin. If anything inside the concrete expands, it creates a lot of internal pressure which cracks the concrete. This can happen due to reactive aggregates. Luckily in India, we don't have a serious problem of reactive aggregates, or what we call as alkali reactive aggregates. Otherwise, you will have to use low alkali cement and also non-reactive silica aggregates. This is not very serious matter as far as our country is concerned. But the other serious matter is the steel inside the concrete. Most often, proper cover is not given. Most often, the cover barriers which we use, the cover blocks, etc., they are porous, and instead of preventing water from entering and touching the steel inside the concrete, it allows the water to enter because it is porous. So corrosion of reinforcement starts taking place. In addition to water, sometimes sulfates and chlorides also enter the body of the concrete and attack the steel as well as concrete inside. And after some time, the protective layer is almost gone, cracks have widened, and this results in steel corrosion. The steel, that is Fe, gets converted to Fe2O3 called the rust, and this rust occupies now 5 to 6 times more volume of steel inside the hardened concrete and creates pressure on your hardened concrete. Depends on the age and the strength of the concrete cracks, and what we say as spalling of concrete Sometimes some chunks of concrete fall, sometimes on human being, sometimes on somebody else, or you are alarmed and say, oh, concrete needs to be repaired. We go further to temperature. Just like a human body is affected by internal temperature as well as the external ambient temperature, we say that when human body has a high temperature, means internal temperature, he is sick, and so has concrete also becomes sick when the internal temperature is high, maybe because of the heat of hydration of cement, or sometimes some aggregates of abnormal thermal expansion are also part of the concrete ingredients. This also is very rare as far as the aggregates in India are concerned. But differential expansion and contraction within the concrete creates cracks. So we have to use either, if it's a massive pour, either use a low heat cement. Pozzolanic additions and slag additions are recommended, or PPC or slag cement can be used in such instances so that the extreme temperatures inside the concrete do not happen. The next we go is the external ambient temperature. Climatic changes happen and large slabs or walls without adequate joints start cracking at places where the engineer has forgotten to put joints. Now this is very, very important as far as the roads and pavements are concerned. Depending on the quality of the mix, I'm saying quality of the mix, also on the grade of concrete, also on the thickness of the pavement and road which you are constructing, the joints have to be designed at a particular spacing. If the spacing, for reasons best known to the engineer, are far apart and not adequate, then concrete will crack in between the engineer made joints. So it is always better. Another strong recommendation goes from me is always cut the joints in such a way that the panels between the joints are square, not rectangular. I will show you what happens when you have rectangular panels. Frost and ice action causes falling on the surface, especially if there is an admixture added for de-icing salts. Now, of course, it is banned. Air entraining is used more often, and quality of sound concrete is necessary when it has to face frost and ice action. The next is the most important is the structural failure. Now, you cannot blame the engineer at the site for taking not proper care or curing, etc. when structural failure occurs. Structural failure happens due to excessive tensile stresses, which causes the cracks. Building settlement, excessive loads after the structure is built and the engineer had not made allowance for that design in the design. Vibrations may be due to some machinery installed, or maybe building being very close to the rail track, earthquakes, and insufficient reinforcement steel. because steel is supposed to take care of the tension in concrete, but if it is insufficient, concrete will crack. So in short, we say correct design of the structure vis-a-vis in which earthquake zone the structure is, in what type of climatic condition the structure is. The structural engineer has to design it properly, taking care of all these environmental as well as the earthquake conditions. Concrete will always crack. You can see here an elderly gentleman sees cracks in concrete and tells the site engineer, and the site engineer sees cracks somewhere else. This happened, this particular cartoon I made, we were giving supply of the cement of 53 grade to the National Stock Exchange, one of the richest clients in the country. And they took every care for getting good material, good contractor, everything well organized, etc. The designer was from Delhi, not from Mumbai. And when the first cracks came in the walls of the basement, they all blamed it to our 53 grade cement. So I was summoned to the site. I went there with my engineer and we were seeing the cracks. The consultant was also made to come from Delhi. And while we were observing the cracks, I observed that the concrete had cracked every 6-meter interval. Every 6-meter interval. So I just smiled at the consultant and told him, very politely of course, that sir, you design concrete mix in such a manner that it will always crack at 6 meters center. And I can design a structure properly reinforced, planning the construction joint so that it will crack at 6 meters, but at a planned area where the joints are provided. So he understood. But he said, no, there is another building here, there also they have used 53 grade cement. But it is not made from your brand, it is made by another brand, and there are no cracks occur. So I said, fine, let us go and visit that site and see what has happened, why there are no cracks. The design is also same, he said, the steel, etc., the thickness of the diaphragm wall, all those are same. So we went there and we saw, and we observed that there were no cracks. Then suddenly I came across a joint. So we took measurement tape and went on both the sides and 6 meters, and we saw another joint. So I told the consultant, sir, here they have cast panels of 6 meters. On the first site we saw there was a big contractor, big client, and they had planned a joint at 32 meters. So the wall had to crack in between because your wall is just capable of taking panels of 6 meters. He immediately changed the construction technique and he said that no, in future, next 4 onwards, you should construct using panels of 6 meters only. So sometimes the design also constrains the contractor to go slow. The design also is a very, very important aspect. And I therefore tell the site engineers not to be easily bulldozed by the design engineer saying that crack has happened because of poor construction. And hence this cartoon. Now we go into the depth of long-term drying shrinkage. It happens generally after 1 to 7 days or much later on also. It happens on thin walls or slabs, mainly road slabs, pavement slabs, etc. Primary causes are inefficient joints. I told you already the reason of one of the reasons of cracks. Moisture differential between the top and bottom surface of the slab or between two faces of the wall. One may be facing the eastern side, so it will get heated up in the morning, and in the western side it will get heated up in the afternoon, so there will be a differential temperature. The the slabs which are flat on the ground or in the buildings, due to, especially due to, these are pertinent to the road slabs, due to differential between the top and the bottom surface, the slab, though not very visibly seen, takes a shape of a saucer. The extreme thing would be like a saucer. Now why that happens? Because there is a more moisture loss at the top and less moisture loss at the bottom. The bottom of the slab of the road is touching the ground and it gets lifted up without cracking. And when the moisture differential reduces, it goes back to its normal position. Now, when I was taught concrete in college, we were told to have a good mechanical bond between the lean concrete which we put on the road and subsequent the pavement. So they should bond together. Now the specifications have changed. We put a sisal craft paper or a plastic sheet on the lean concrete which we put and then put the pavement concrete on the top. Because if there is a mechanical bond between the lean concrete below and the concrete road at the top, the movement of the saucer type of action of the top layer of concrete, which is the pavement concrete, will be restricted and you will get diagonal cracks on the top surface. Secondary causes are excessive shrinkage, because if you have used too much of cement, adequate distribution steel or rich mixes, again rich with cement or rich with fine materials, cementitious materials. Preventive measures are reduce water content and cement content. The IS has recommended maximum cement also as well as the minimum cement to be used. So it's a very thin margin between the two, minimum and maximum. But the engineer has to manage within that. Increase distribution steel, protection of concrete against rapid changes in temperature and surface moisture loss. Curing for extended period, 28 days or more, as I said earlier. More you cure, the more concrete will endure the rough usage and it will give you a longer life or durability. Reduce restraint with the base and subgrade, as I said earlier, by putting a plastic sheet or a sisal craft paper, so that the should in case there is a moisture differential and the concrete gets lifted up, it will not be restrained by the mechanical bond below. between the plain concrete and the pavement concrete. Here you can see the early days Mumbai roads, they had cut rectangular joints, and the longer length of the rectangle started giving way, and you got some more joints between them. Ultimately, the panel became almost square. And the concrete told the engineer, look, I expand and contract equally in all directions, so don't be funny. Don't make rectangular joints. But these were the early days of concrete roads. Then they have, I think, improved on the design of the joints also. If there is a manhole in between, the engineer tried to avoid making a joint. And here you can clearly see the concrete, being more intelligent than the engineer, has made a joint of his own. But this joint doesn't look very good, may not last, and is likely to have potholes later on with repeated usage. So one has to have a joint, and the panels should be reasonably square. You can see here, concrete has made a square panel by itself, not the rectangular one which the engineer made. Further, cracks can be classified in two ways: the dormant cracks and the live cracks. Dormant cracks are cracks where width will remain constant. For example, shrinkage, once it occurs, it cracks the concrete and the crack remain almost the same. But the danger is it will allow water, moisture, etc., chemicals, and cause a problem of durability. Temperature gradient also, these are dormant cracks. But the live cracks are due to imposed load and thermal expansion and contraction. An imposed load could be due to earthquake, or due to addition alteration, or due to addition itself of a heavier type, and therefore these cracks are live cracks and dangerous. The best way to judge a crack at the age which it has appeared. So it is always very important that the consultant must visit the site of repairs. And if it's an occupied building, ask the occupants, when did you see this particular crack? And if the occupants say, oh, we have seen right from the day we are occupied, then it could be plastic shrinkage crack or plastic settlement crack. Or if the occupant says, no, we saw it about 2 years back, it could be a corrosion crack, or it could be due to the load somebody has put extra in the building, or if there are different types of cracks called the settlement cracks, which I'll show you a little later. This could be due to removal of early formwork and support system. So that could be initial. Or if it has taken many years or few years, maybe depending on the type of concrete and the precautions you take during construction, could be due to chemical attacks from outside, chemical reaction from within, like the alkali silica reaction. So depending on the age, the engineer can guesstimate or realize what type of a crack has appeared in the building which he is being consulted for. If you see the IS 456, it recommends crack width limitations. from 0.3 mm to 0.1 mm. The 0.1 mm is for water retaining structures, concrete in aggressive conditions. 0.2 mm is members exposed to effect of weather, exposed to moisture, or in contact with the soil and groundwater. And 0.3 refers to structural members where cracking is not harmful and does not have any serious effect on reinforcement, corrosion, or durability. So these are the various crack limitations. Now we go into some structural cracks. The first and foremost is the flexural crack. This crack occurs in beams and sometimes even in slab, originates in the maximum moment region, maybe a single or a group of cracks, maximum width at the top and bottom, like you see in the sketch here. If it's a fix and moment, then it can occur at the top also. And if it's a free span, then it can occur at the bottom. Flexural capacity of the beam is inadequate and cross section or main reinforcement insufficient. So that means these flexural cracks have occurred mainly due to the design. Shear cracks. It is very easy to identify shear cracks. They occur at 45-degree angle. They don't occur vertically or in any other direction. Originates near the support and may be single or in groups. Maximum width at neutral axis region or at the bottom. This is the neutral axis region when there is fixed end supports. And here you can see at the bottom. So shear capacity of the beam is inadequate, cross section or torsional reinforcement insufficient. This is an earthquake attacked building and you can see the shear cracks very clearly. Now what has happened was, this is a photograph taken in the plinth of one of the buildings in Ahmedabad. And why shear cracks have occurred here? Because there is a beam supported on the main beam itself. And the earthquake took place in such a manner that this beam went on banging the supporting beam. As a result, there were some shear cracks visible on the main supporting beam. Because this beam went on hammering, creating shear failures in the main beam. Very interesting, but it has happened. The torsional cracks occur near the point where there is maximum torsion region. Generally uniform width appears and the crack is over the periphery in a helical manner or in a helical form. Torsional strength of the beam is inadequate, cross section or torsional reinforcement insufficient. You can see here, this is the torsional crack. Of course, this is a building in Turkey, which failed. And of course, the column on the top has gone for a toss. But a torsional crack is visible on the beam below, which is helical. And you can see it from the other side also, if you want to go there and risk your life. Bond cracks, nothing to do with James Bond. These are bond cracks where corrosion has occurred in the bars, and once corrosion occurs, it debonds from concrete due to the formation of the rust. And this is a very, very known phenomena. in any coastal area of India, that the bars start rusting and start debonding, and resultant cracks allow more water to go in, etc., and create problems. It can also be due to fire damage. So when one notices a crack like this in Mumbai or in Kerala, many a times the consultant takes the client for a toss, or a contractor takes the client for a toss. And he says, no, no, we have to do the non-destructive testing, the ultrasonic testing, and this and that, etc. Even the latest specification of repairs of municipal corporation have included many ultrasonic testing to be done, which in my opinion is not right. So when you see corrosion like this, it's very simple. Just remove the covering concrete and you will see a bar corroded inside. You don't have to do all these fancy tests when there is a corrosion crack. You have to replace the bar if it is corroded very badly, or repair the bar if it has not corroded so badly with chemicals available, and then putting a inhibiting layer of cement paste over the bar and then finishing it the way you normally do the plaster. You can see here a badly corroded reinforcement steel. The soffit has corroded and the building was repaired once and again needs repairs. Many a times there are construction joints. You see, we make an RCC framework and build the wall inside. And the wall expands and contracts in a different way than the RCC framework. And therefore, you have separation cracks. Now, many a times the wall is not constructed properly from the outside, etc. So there are obvious large separation cracks appearing and allowing even the leakage of water during the monsoon inside, because there are lots of gaps left, and hurriedly done plaster from the outside, maybe in only single coat, etc., without first sealing all these joints. So it's very, very important that when you are staying in a building where there are bricks and blocks used to make walls, you must be very careful that before you do the plaster, you pack all these defective joints from the outside, because the water comes from the outside, not from the inside, and seal the cracks, cure them for at least 3 to 4 days or 7 days, and then do your first coat of plaster, and later on do your final coat of plaster. This is the way you have to pack the joint between the brickwork and the RCC. Sliding cracks. Sliding crack occurs because the formwork from below this beam during the construction was either accidentally removed or removed with full intention of making use of it at the higher elevation of the building, and the beam settle. Or this happens at the supports. These are right through cracks due to the disturbance of the formwork when green concrete was there, or early de-shuttering. Like this. Sometimes the sliding will be very high, the entire structure will collapse. Structural cracks, tension cracks. Unfortunately, I don't have a photograph. I missed one opportunity when such cracks had appeared somewhere in Navi Mumbai. One of my engineers who had changed his job and was working for some builder. He telephoned me and he said, "Sir, there are joints which are parallel to each other, and this," I told him, "could be due to the tension in the beam." Immediately I asked him, "Was it a concrete truss which had one of the beams cracking like this?" He said, "Yes, it is, sir. It is a truss of a building, RCC truss." So I said, "Just find out from the consultant whether the member which has cracked is a tension member and get the design corrected." So immediately he came back and told me, "Yes, it is a tension member." So I said, "Then your design has to be corrected. It has failed in tension." Normally in our buildings, we don't see such failures or such cracks because the beams are not under tension. But in a truss, where some beams are under compression, some are under tension, this can happen and can be a serious problem, not only of durability but also of a failure. Now we go to columns. Columns can crack, by splitting. Now you can see here, there are rolling shutters on either side which is now supporting the column. This column has completely failed. Now what happened was, during the earthquake in Bhuj and in Gujarat, you can say, many columns failed like this. The problem happened was, the columns, though they were using high yield tensile steel bars, were getting the steel supply from re-rolling mills. And the scrap was of maybe mild steel or some other steel and rolled into a bar which looked like high tensile steel bar. Then many a times people in the construction industry, the masons and the carpenters and those who are in charge of the building, were not engineers. They were thinking that the stirrups in the column are only to support the vertical bars till you concrete the column. So any spacing, they will put these stirrups. During an earthquake, stirrup plays a very important part to stop a column from failing. But here you can see either the stirrups are very far apart or not of adequate strength, and therefore they just separated from the concrete. And due to the load coming from the top of the building, the concrete actually got crushed and it looks like a cube failing in compression without any steel, of course. So this is a crushing failure actually, and the entire column has split. And therefore, of course, this building cannot be repaired, it has to be reconstructed. There are several columns like this. But fortunately, some columns failed, some did not. And I really don't know what has happened to the final thing for the building. Another cracks which you see are the bond cracks. Wherever there are corrosion, here there are more corrosion in the balcony slabs, etc. Thinner sections, less cover, more exposed to the rain, etc. And there are cracks in the column also. So bond between the reinforcement bars and concrete not satisfactory, maybe due to corrosion or fire, but here it is of course due to corrosion. Then there are diagonal cracks, and then there are horizontal cracks. The diagonal cracks run diagonally across the section. You can see any weak point and the crack will occur. There could be reasons like capacity of the column is inadequate at that particular point, cross section, or maybe the reinforcement may be insufficient, or maybe there must be some porosity in the concrete at that region. The others are the horizontal joints. Now generally what we construct is a column up to a certain height, then put beams and slab on the top with a small region of the column, what we call as column ka topi, cap of the column. And luckily here only the plaster has peeled off, and the column, the construction joint has shown visible horizontal crack, but the concrete was good and solid, so they could restore by replastering the building at the basement. No need of a very laborious, and because it was only a construction joint which was exposed due to the shaping of the building during the earthquake, and some plaster peeled off. Now we just go through this Qcrete model. Was developed by Qcrete. I don't know the year in which he developed, but you can see here there is an initiation period T1 and there is a propagation period T2. Now what happens is when concrete is born, it is alkaline. Alkalinity in the concrete around the steel do not allow concrete to corrode. It inhibits corrosion, and therefore when the chlorides or water starts penetrating into the concrete, for time T1, no crack appears. Because once the chloride and water enters the concrete, gradually the alkalinity is lost and corrosion starts. And it goes on increasing and increasing and increasing till the end of life comes and the building will collapse. Suppose you repair the building at this stage, again, due to if the repairs done are good, you can have another T3 or T2 life, and then T3 will start later. So every time you repair a building and do it sensibly and properly, you increase the life of your building structure. And if there are structural cracks, then you have to be very sure that just repairing will not do. You will have to even strengthen the structure. There is a nice model made. You can see there is a passivating layer which does not allow the reinforcement of steel or reinforcement inside the concrete to crack. Even though there are minor cracks, they are all isolated, but when the chloride and water starts seeping in, the cracks unite and pass on the water on the bars, and then you can see flaws, reinforcement passivation is lost, and corrosion happens. We always say united we stand, but for cracks you should say united you fall, because they are then dangerous. If the cracks are isolated and not united, your building can have an extension of life till they get united, maybe due to loading, unloading, due to water seepage, etc., due to any reason. This is a beautiful building, PWD design. It's the ESIC hospital in Ahmedabad, and This photograph was taken just after the earthquake. There were some patients in the hospital. The engineers felt that after the earthquake, a lot of spalling and a lot of cracking was observed. So it was time to hospitalize the hospital and tell the hospitalized patients to leave and go to some other hospital. So when this is just an example, I'm showing that when we are doing this, design was good. The building did not collapse like many buildings in Ahmedabad, but it was just good enough to allow the people to leave the hospital. The main reason of such a deterioration taking place was poor maintenance. So it's very, very important that good design should be supported by good maintenance if you want your infrastructure like hospitals to survive the calamities which the human beings face. This is a building. There were three buildings. One of them collapsed in one of their wings somewhere in '94. They are called the Poonam chambers. Originally, the architect had made a nice fascia with marble on the top and some fins for him, giving some architectural effect. But it was facing the creek near Worli, very corrosive environment, and maybe not constructed properly in those days, and therefore the concrete started spalling and the protection of marble was no more. It also started falling on the parking lots and people below. And after the collapse of the earlier building, after the collapse of the building adjacent to it, they decided to refurbish Poonam Chamber 1 and 2. And they have removed marble, they have removed concrete, they have removed the decorative fins, etc., and depended on steel and aluminum to give the fascia of the building. So cosmetic effects don't last if the concrete below is not good. Here you can see a typical slab of a badly damaged building due to monsoon but delayed repairs. We are lucky that the fan is still on the ceiling. It could also come down. So this is due to all leakage damage, corrosion, etc., and spalling of concrete. One important lesson I have learned that curing is a must. You cannot neglect the curing because it is the last step of concrete making. Curing is very, very important. It increases the life of the structure because with good curing, you can gain strength of the concrete, even of the plaster. If a well-cured plaster without cracks is there, it can even afford some protection against future erosion of bars, etc. And it may not give you the strength a structural member gives you, but it can give you the protection which otherwise would not have been there if the plaster were not existing or if the plaster was badly constructed and cured. I'll give you one example. Chandigarh city, the well-known architect, French architect Corbusier, had designed most of the buildings when it was built for the first time. And he had the fancy of saying that we should make form finish concrete. And he had specified everywhere form finish concrete without plaster. And when now after years where a lot of buildings, Corbusier's form finish concrete had to be extensively repaired. Why? Because the plaster was not there. If plaster would have been there, probably the form finish buildings would not have been seen as form finish, but would have looked like our normal buildings, but would have had the protection, because Chandigarh is not in a place where there can be excessive corrosion. But because the concrete was designed that way, of course, if they had taken the high strength concrete and the concrete which we are now specifying for high-rise buildings in Mumbai, etc., those type of concrete can survive even if it is form finished, but not M20 and M25 grade concrete cannot survive. And I'm sure this must be either M15 grade or 20 grade concrete when Chandigarh was built. Now we come to the fancy part of my presentation. I could not get all the photographs, so I have made sketches and given them. How carelessly people or the occupants modify their buildings. The do's and don'ts. This is the, on the left hand side is the original chhaja and a window. Some guy who occupied the flat a little later, the architect is never aware, the engineer is not aware what he did. He wanted some sitting accommodation, so he provided concrete on the chhaja, which was cantilever, loaded it, and also made a sitting arrangement and some pots to beautify. But the original building, this was only a chhaja, so cracks developed. So people do lots of architecture of their own and destroy the building. A balcony is kept for people to see the beautiful birds, trees outside. But somebody in the family got married and they needed an extra bathroom. So they converted one of the balconies into a bathroom. Can you imagine putting this heavy bathroom utilities inside? It's a cantilever slab, etc. Then you do plumbing, and then the balcony at the lower elevation, the neighbors will complain because they are leaking. So one has to ban all these additions and alterations. Many buildings, their life have been curtailed because of erratic additions and alterations. And municipality has now become more strict, at least in Mumbai. But I hope this strictness also culminates in stricter action against people who do this sort of additions and alterations. This is another example. People believing in Vastu would like to have a waterfall on their balcony, and they make a waterfall, telling the neighbors, oh, we have taken adequate care of this leakage, etc., and we have put the best waterproofing treatment, this and that, but they have loaded the balcony also. So fresh cracks must appear. And the neighbor below also had the privilege of Vastu prevention by having a waterfall in his flat. Ultimately, this tenant was told not to do run water, so now the waterfall is dry, but the load remains on the balcony. But at least the water seepage and leakage is stopped. Sometimes some people would like to shift the partition wall thinking that it is only brick wall. Hope it is not an RCC wall, which is a shear wall. They don't bother even about that. They will shift that also because they want one room to be bigger than the other. And therefore they transfer the lightweight wall. And even the consultant will give them permission to transfer this lightweight wall, etc. Because it is a very thin wall. Yes, the structure may not collapse, but it will definitely get an eccentric loading because of the lever arm, and it will develop some cracks, etc. And maybe after a few years create some problem because the wall is not in its original position where the beam wall would have transferred its load onto the beam below and onto the column below. So this is very, very important. People take it lightly, this type of, and even some engineers certify such of. This is the husband pacifying his wife that don't worry, now there will be no water supply. I have the largest tank installed in our toilet block. And after some time, the entire toilet block along with all the tanks in the neighbor below collapse. The building has collapsed. Now, this sort of things are also happening. And remember, toilet blocks, kitchens are all wet areas. And if their original RCC is not done properly, especially the old buildings in the 1960s and 70s, earlier buildings were done in the British Raj, they were of much better quality than the later Raj which took place, and there was cement scarcity, etc. Resulted in many buildings losing their bathrooms, balcony, and all the wet areas because they had heavy corrosion not repaired and so they collapsed. And plus an additional weight of the water tanks. This is one such example, the Akash Deep building. The old two-story building was extended by 5 floors on the top, so it became a 7-story building. The galas or the apartments or the blocks inside were sold to automobile spare part dealers. Everyone started making a mezzanine floor to store their spare parts. The badly constructed building, extension of course, corrosion, Mumbai weather, additional loads due to mezzanine floors and the weight of the automobile spare parts. In those days, mind you, they were all steel spare parts of Ambassador and Fiat. Nowadays, we have plastic spare parts, so they may not be that much in weight. Resulted in a collapse, and this building, even though called Akash Deep, was no longer giving light in the Akash, it just came down. 7 people died. The building collapsed in the night, fortunately. The building was located handshaking distance from the rail track between 2 railway stations, Bombay Central and Churchgate Main Line, from where the trains locals used to pass. Luckily, it fell in the night. There were no locals. Should in case it had collapsed and fallen on the locals, many people would have lost their lives. Only 7 people who were incidentally like watchmen and staying, footpath dwellers who were staying in the night in this isolated commercial building fell prey to the collapse. Now, the lesson which everyone in Mumbai got was that the BMC revised their building bylaws and made it compulsory that all high-rise buildings should be at least 50 feet away from the rail track. Because if you see in the olden Mumbai, the buildings are almost touching the railway. And if they collapse, they'll crush the railway wagons and the people inside. So this new law came about, but if a high-rise building is say 100 meters tall or 200 meters tall, the way they are constructing now, and if it collapses, it will definitely fall on the railway. It may make a bridge and maybe hit the buildings on the other side of the railway. So the best solution would be to make proper construction, yes, a little bit away from the railway line, but not allow additions and alterations, especially in the weather like Bombay, where it's very corrosive environment, to cause such accidents. Many a times people think that RCC, oh, it can be tempered, it can be changed, again plastered. So they put their electrical conduits, sometimes even water supply pipelines, etc. Sometimes they don't remove the old flooring and they put additional flooring tiles every alternate year because the height does not matter. It is good enough for people to walk inside the room. But this adds load to the building, and this certainly damages the RCC work. Even if you do it in the brickwork, it is okay, but not in the reinforced concrete. Very, very dangerous, especially if you are concealing the pipelines. I have seen in many old buildings, people have gone about doing such rectifications, or I won't say rectification, I would say additions and alterations, and have damaged the buildings. Some of them have even collapsed due to this. The architect never knew when he designed this building that there will be something called cable TV. This is a basement column, not basement column, sorry, stilt column, and about 6 or 7 stories are on it. And the occupants are unaware that this person has drilled through the column, cracked the columns, damaged the column, and put cables bypassing the column in such a rough manner. I would say these are the butchers of our buildings. They slaughter the building and sometimes the building falls. Luckily, this building did not fall, but I was invited by one of my Tata colleagues because he had a flat there and he told me that somebody has done this. I have to explain to them that whatever you want to do, don't touch the columns. This is in Kerala, Cochin city, and there was a problem of going into the basement, a 9-story building on the top. This is the lower region where beams are supposed to be very important to prevent the sway in the building, etc., and maybe fall. The jeep used to come and the carrier on the jeep used to hit the beam. The carrier on the jeep. So the owner of the jeep was smart enough to convert the beam into an arch, and he removed all the bottom steel, maybe even some shear bars, etc., and have made it to shape so that his jeep with the carrier can now enter the business. Should in case a earthquake of the type in Bhuj takes place in Cochin, maybe we will see the 9-story building coming down. So till then, you can cross your fingers and wait for such calamity to occur. This is again sheer murder of the beam. You can see. There are many people residing in Mumbai, and there are many buildings which are designed to take earthquake, and they have put shear walls between the columns, RCC shear walls. But many people think that they are just like the brick walls, they can be demolished and removed and then kept open for a room to become bigger, etc. And many people have done these changes. The buildings are surviving because earthquake will come at any time, we don't know, or may not come at all in my life or in everyone's life. And the building may remain safe. But should in case a building faces an earthquake and the shear walls are removed, there could be a very big failure. This is a different problem. When Bombay city was being extended through the creek areas, which are very soft clay and needed very good foundation, and the foundations were done in a bad manner, some of the buildings actually started sinking. Some of the buildings faced differential settlements, started cracking, and were on the verge of collapse. So they were demolished and rebuilt after making sure that the foundation below is proper. Foundation is the key to safety of a building. Foundation repairs are the costliest. You may even have to demolish the building and rebuild. So all the more precautions are necessary for constructing new foundations. I was involved in construction of a power station with tall chimneys and heavy loads in a creek area. We have constructed that, but with proper precautions and proper foundations and design and quality control. So there are no differential settlements even after the span of 30, 40 years, and no problem to the running of the power station. So if you construct things properly, whereas this building has to be demolished within a few years' time of its construction. One more building resulting in eventual collapse. This was a building called Shiv Chandan building. We give very good names to our buildings, in the name of God, etc. So this was a 4-story building. There were 2 buildings, one behind each other, built by the same builder during the same time. The building in the front had a bank on the ground floor, and the rest was residential. There were very big cracks and corrosion to the members, etc. Members of the structural members of the building, not human beings. And the building was in a bad shape. And one fine day when it was pouring in Mumbai, and the bank employees came to the building and they were working on the ground floor, they heard some creaking sound coming out of RCC building. So they alerted the manager and told, no, we cannot work in this bank. This is very dangerous, etc. The manager, like all managers, said, no, no, carry on. This has been there for the last 15, 16 years. No problem, carry on. But somebody, a wise man, called the fire brigade as well as the municipal authorities, and they saw some chunks coming down and they said, no, immediately vacate the building. So at 10 o'clock, this fiasco happened, and at 6 o'clock, the Subsequently, the building was vacated. All people removed their valuables as well as they themselves came out. And at 6 o'clock in the evening, the building collapsed. The 9 people died in this catastrophe. Why? Because the building collapsed on a next compound. There was a bakery and it collapsed on that. The bakery man was also told to stop baking his bread and close the bakery because this building might fall in any direction. All the other surrounding buildings were all alerted and they were also partially vacated. But this man, the owner of the bakery, said, no, no, nothing will happen. We are in the next compound. And unfortunately, the 4-story building collapsed in this bakery. The 8 workers and the owner died because of this collapse. And you can see one balcony sitting on the other balcony. All the columns had got completely corroded and they came down with a thud because the building could not take the aggressive environment further. My friend was residing in the next building. Fortunately for him, that building did not collapse. The first one in the front was supposed to go first. And he rang me up at the middle of the night saying that, sir, can you come and inspect our building? I said, what, at this time and with heavy rain? Sorry, I will come in the morning if I can. So he said, okay, fine, you can come in the morning and we'll wait for you. So I telephoned my guru, Mr. Remedios, and we both went there from Dadar. We started at 6 o'clock in the morning. Remedios came from Kolaba and we reached there at about 6:30, 7 o'clock in the morning. And inspected this building, inspected the other one. And we found that the other one was also badly corroded but was repaired regularly. And there were cracks visible. We never knew what was the exact reason. But later on, when this building was demolished and reconstructed, my friend told that the foundations of this building were on sawdust because there was a sawmill there. Where do you distribute all the sawdust? So he used to distribute in the pits excavated for foundation and then build a foundation on them. So there were all differential settlement cracks, etc. And his building also was a victim of this, but had somehow survived for 16 years because of the repairs and patch-up work which they were doing. Now, as the building collapsed, the municipal and the politicians became active and they took the structural engineer and put him behind bars. And his license was cancelled so that he cannot practice anymore. Now, during my lecture, in one of the workshops in Ambuja Singer, I showed this slide and made the comments which I made just now. And someone told him that you are behind bars and you are in trouble. Why don't you go and meet Mr. Dorley? He has some news for you. The building has collapsed not due to your design, it has collapsed due to some other reason. So he immediately came rushing next day and met me, and then I told him, you go and meet my friend who is staying in the adjoining building. He went and met him also. And later on, the whole thing was exposed. And even my friend's building was demolished and reconstructed because of the same reason. They also found the foundations on the sawdust. So what does a poor architect and poor designer do? Hello. Now, just to end my lecture, this old lady was, we had gone to inspect one of the buildings, and this old lady was praying. So my engineer who had gone there asked her, Madam, आप कैसे हो? So she said, okay, I am old and now my problem is, first somebody told me there were cracks in the wall and column, that you repair it with tiles. So I spent a fortune repairing the entire flat with tiles. And now the tiles are cracked. And now they are telling me they want to repair the structural members of the building. I have no money, so that's why I am praying. Maybe her prayers will be ended soon because she's sitting below this tree. If one chunk falls on her, all her prayers will be ended. She won't need the repairs, she won't be there. So this is a very important thing, that when you can repair properly, when you maintain it properly. No slipshod way of repairing it should be allowed. So I end my lecture with a big thank you. I'm thanking the designer for designing this building with a long beams so that even if one column in between got crushed like this, like the cubes which we crush every day, day-to-day testing. So this is a field testing of our concrete, and this is the lab testing. I thank my wife for assisting me in this webinar venture. I thank the participants for your presence and good wishes. If you have any questions, please email to Shelly Fernandez, Shelly FSF213@gmail.com, and some of the questions will be answered. The first 10 will be answered by me. The rest will be selected and answered by Shelly's team. I once again thank Qcrete, Shelly Fernandez MD, and his staff, Kaushik and Ishwarya. They helped me in this webinar, and they also should be heartily thanked for having done 3 jobs, not only for this webinar, for the other earlier 2 also. So thank you. I wish you all good health. Take care. These days, COVID is the biggest enemy of human being. So keep good health, and my best wishes to all of you. Thank you.
Thank you all for hearing this wonderful lecture by Dodi sir. I can say this is one of the most comprehensive lectures we have heard on cracks, and the subject was covered extensively, and I can say this is one of the best lectures I have heard in my life on cracks, and some of the aspects are really dealt in a very, very beautiful way actually. Thank you, Mr. Dodi sir. Thank you very much.
Thank you. Thank you.
And thanks to our MD, Shelly Fernandez sir, for organizing this wonderful lecture. And I thank once again all the audience participants for coming in the morning and listening to this beautiful lecture by Dodi sir. Thank you all. Thank you.
Kaushik, how many people attended the lecture? Can you tell?
We'll send the report. Sir. I have to learn the sound.